Welcome to Mac 2311 for engineers, exam 3, problem number 8. So in this problem, they go ahead and they say that you have a rectangle that lies on the x-axis and y-axis and has one corner on the origin, and the other corner is on point P, which is on this curve here, which they give you that curve, x plus 12 over x squared. And then they want you to go ahead and say what x value would minimize the area of this rectangle. So this is just an optimization question. So what we want to do is we need to have a primary equation and a constraint equation. So the primary equation would just be the area of our curve, of our rectangle. And we know that's just x times y, right? Because this would be your x and this would be your y. So now our constraint equation is just the curve itself, because you know that y is related to x by the equation given. So now we can go ahead and take this y and feed it into that y, because you always want to get your primary equation in terms of one variable. And then once you have that equation, you can go ahead and derive it, set it equal to 0, and solve, and get your answer. So that means our area, solely in terms of x, is just going to be x times this thing. So it's going to be x squared plus 12 over x. So if this is what a is, the area, we can go ahead and find a prime and set it equal to 0. So the derivative of this would just be 2x minus 12 over x squared. And then we can go ahead and get a common denominator. That gives us 2x cubed minus 12 all over x squared. So that's equal to 0 when? Well, it's just when the numerator equals 0. So it's going to go ahead and give you 12 is equal to 2x cubed. Cancel the 2 out with the 12, giving you 6 over here. And then cube root both sides. So when you cube root this, you get x is equal to the cube root of 6, which ends up being answer choice A. That's all there is.